Hello, my lovely, darling, wonderful students. This week we are going to look at solving logarithmic equations. Woohoo! Last week you ended the week thinking about a problem like this. Let's say we have the log base 3 of x is equal to 4, something like this. Now, if we put this into exponential form, another form of saying this is 3 to the 4 equals x, or 3 times 3 times 3 times 3 is equal to x, or 81 is equal to x. So you, in fact, have already actually solved logarithmic equations. And it's not too far to say, to go from here and say, well, then, what if I fancy this up a little bit? What if I say log base 2 of x minus 6 is equal to 5? Well, from there we can put it into exponential form and say 2 to the 5th is equal to x minus 6. And we know 2 to the 5th is 32, and we can solve from there and say that x is indeed 38. Huzzah! But what if we complicate things? We are not interested in the easily done. We like a challenge. So let's say we had a problem like this. Log base 4 of x plus 12 plus log base 4 of x is equal to 3. Now here we don't have a single logarithm that we can easily translate into an exponential. So what must we do? Let's make it into a single logarithm. Let's condense. And we know condensing from last week. We know that when we add logarithms, that's the same as multiplying the arguments. So we could actually call this log base 4 of x times x plus 12 is equal to 3. Well, that would mean that 4 to the 3rd power was equal to x squared plus 12x. And from there, we can say that 64 is equal to x squared plus 12x. We'll subtract 64 from both sides because we notice that this is a quadratic equation. 0 is equal to x squared plus 12x minus 64. I know Hoover is out there somewhere trying to do the quadratic equation, the quadratic formula on this, but I know that if I'm multiplying to negative 64, I'll need a positive and a negative. 64, 16 times 4, positive 16, negative 4, that will give me the product negative 64 and the sum positive 12. Now from here, I'll use the principle of zero products. Any two numbers that multiply to make 0 means that one or both of those numbers is 0. Which then means that x could equal negative 16 or positive 4. But remember our rules about logarithms? These numbers here, we call them the arguments. The arguments can't be negative. Now, it may seem counterintuitive because in the real world, arguments are negative, but in the math world, they're not. Therefore, our only answer is 4. Let's check it. Log base 4 of 4 plus 12, 16, plus log base 4 of 4 is equal to 3. I don't know about that. Let's check it. What is the number? 4 to what number equals 16? 4 squared equals 16. And 4 to what number equals 4? Well, 1. 1 plus 2 is 3, so it does work out. Now, we're going to try one more example. It might seem crazy, but it's actually quite easy. The natural log, we could use any log. We're just going to use the natural log. The natural log of 4x minus 4 is equal to the natural log of 2x plus 11. Now, you may be tempted to do some work with subtracting and quotienting and equaling 0, but look here, if the natural log of some number is equal to the natural log of some number, what can you say about these some numbers? Well, I would hope you would say that they must be equal. 7x minus 4 is equal to 2x plus 11. When we subtract 2x from both sides and add 4 to both sides, we get 5x equals 15, which tells me that x is 3. Let's do a quick check to make sure that we don't have any negative arguments here. the natural log of 21 minus 4 is equal to the natural log of 6 plus 11. Is the natural log of 17 equal to the natural log of 17? Indeed it is. Huzzah! Huzzah!